All right, welcome back. Accidentally hit stop instead of pause on the last video, so this is going to be part 2 of 104.6, which is the second to last section we need to get through here. After .7, I can actually take the test. So let's get through these guided exercises. The first one is, what is the parameter of a chmod in symbolic mode to enable the sticky bit on a directory. So we know that symbolic mode is using the symbols U, G, and O for user, group, and others to set the permissions, and then we also use the symbols W, R, and X for read, write, and execute. So the parameter for chmod for the sticky bit, now those are special permissions, so part of me wants to just immediately jump and say X, but let's look at the help. It's never a bad idea to look at the help. So chmod -- help. So actually we got to look at the man page for this. So although we do see the we do see this here, which tells us in a regular expression what the syntax is. So it's U, G, O, or A, user, group, others, or all, and then plus, minus, or equals, and then the settings here. So we do have this special setting S. We also have a special setting T. So what is the parameter for chmod in symbolic mode to enable the sticky bit on a directory? I'm going to go with the parameter T. Let's see if that's the correct answer. The symbol for the sticky bit in symbolic mode is T. Since we want to add this permission to the directory, the parameter should be plus T. So didn't get that completely right. The full answer is plus T to add the permissions. But if it was a multiple choice or something, I'm pretty confident I could have gotten that right. So yeah, looks good to me. All right, so the next one. Imagine there is a file named document.txt in the directory /home/carol/documents. What is the command to create a symbolic link to it named text.txt on the current directory? All right, so the command and on the current directory. So there's a few ways you could do it, but my answer is going to be ln-s. That's the key. Using the correct command with the correct option passed to it, which would be ln-s. And now you got to feed it the target. So here's where you could feed it a relative path for the target, but then the link is more vulnerable to breaking because it depends on where the shortcut exists in the file system, whether or not the link works. So it's better to use absolute paths. Start with a /. So this is how. So this is my next part of the answer. Okay, and then we want to create it to the shortcut file named text.txt. So all we need to do is type text.txt. So this is my full answer. Let's see if it's correct. Okay, so ln-s is the command to create a symbolic link. Since you should specify the full path to the file you are linking to, the command is this. And see, now I made the same mistake. Remember the mistake I made before? All I did was I specified the directory. I didn't specify the full target. The file is the target. So I got this one wrong. So it's really important when you're writing down a target. You write down the bullseye, not the ring around the target. So this folder is the ring around the target. The bullseye is document.txt. So this is the full answer. My answer deserves 0 credits. All right, so the last one, explain the difference between a hard link to a file and a copy of this file. So, okay, so a hard link to a file has the same inode data that points to the same data on the disk. A copy of the file has the same data on the disk at the moment it was copied, but then it can be changed. A hard link file, if you change either one, it will and hold on, let me pause it and be right back here. It's just, I can do this without pausing. It's just I kind of I think I need to change up my walking on this treadmill a bit because I almost fell. But okay, no, I'm fine. Okay, so so I'm just trying to be safe on this treadmill because that's kind of a concern if I roll an ankle or fall and hit my head. This is not a good solution. I want to do this long term. I don't want it to be a short term thing, so I'm trying to do it safely and in a way that doesn't destroy the treadmill, which it's already at huge risk because I'm 40 pounds over the weight limit. But yeah, okay, everything's good. So I think I just need to, yeah, everything's good. Okay, so explain the difference between a hard link to a file and a copy of this file. So we did that. A copy of the file doesn't affect other copies once it's made. So if you have a file called file 1 and you copy it to file 2, when you change file 1 or file 2, it will only change that file and won't change the others. If you make a hard link, then you have file 1, and then you create a hard link named file 2. Now your changes to file 1 or file 2 will change the other file as well. So that's one major difference. Let's see what the official answer is. Okay, so a hard link is just another name for a file, even though it looks like a duplicate of the original file. For all purposes, both the link and the original file are the same, as they point to the same data on disk. Changes made on the contents of the link will be reflected on the original, vice versa. So yep, that's what I said. A copy is a completely independent entity occupying a different place on the disk. Changes to the copy will not be reflected in the original and vice versa. And the other thing to say about that is the copy has different inode data as well. So if we go into experiments and then we say let's take a look at the inode data of file 1. There we go. So 9967681. If we were to make a copy of it, okay, and then we have to give it a so we have to give it a target to copy, which is going to be file 1. And then the other thing is you can create a copy in its own directory too, because it's a different file. If it was the same file, it can't exist in the same location, otherwise it's a duplicate file. So, and then if we do a ls-i, now we can see file 1 copy has different inode data. If we were to create a hard link, it would have the same inode data, and we couldn't create it in the same location in the file system, otherwise it would be an exact duplicate. And exact duplicates are not permissible, even though a hard link essentially is an exact duplicate in a way. Well, actually, that's not a good way to think of it. A hard link is just another way of accessing data on a disk. So it's like establishing another doorway to the data. So like if you have a house, the data's in the house, you can get to the data through going the front door, or you can create a hard link which allows you to access the data through the backdoor, the hard link. So that's different than a copy. A copy would be to build another house with that is exactly replicated the original house. All right, so explorational exercises. Number 1, imagine that inside a directory you create a file called recipes.txt. Inside this directory, you will also create a hard link to this file called recipitas.txt and a symbolic or soft link to this called recepti.txt. There we go. The contents of the directory should look like this. Remember that as a hard link, receiptas.txt points to the same inode that recipes.txt is assigned. What would happen to the soft link recipe.txt if the file recipitas.txt is deleted, and why? So this one I already know the answer to. It's that the link would break and it would show it's a broken link, and that's because it no longer points to a valid target that it actually exists in the file system. But let's go through. It's a explorational exercise, and let's get the hands-on practice. So now we could imagine it, but let's just go ahead and create it. So let's create a directory, dir recipes. We'll switch to it, and then we'll create this file. All right, and then now we're going to make a shortcut to it. So this is a hard shortcut. Okay, so you can create it in the same folder, but you have to use a different name. If you use the same name, then since it's a hard link, it's exactly the same. There's no differences at all, and it's an exact duplicate, and you can't have duplicates. You could use the same name if it was a soft link, as far as I know, but you know what? Let's try that. So the next thing we're going to do, and we can see this is a hard link because the inode information is exactly the same. So now let's make a soft link. So we're going to do ln-s for recipes, and then let's use the same name. Okay, so actually I was wrong about that. You can't use the same name whether it's a hard or a soft link, as long as you're in the same present working directory. Alright, let's follow along with this next part. Looks good to me. So the contents of the directory should be like so. Let's take a look. Yep, that's what they look like to me. Just remember that as a hard link, this one here, this is a hard link, points to the same inode that is assigned. So this is the inode here, and we can see that it's the same. What would happen to the soft link if oh, this is interesting. This is actually kind of more interesting than I thought it would be. So what would happen to the soft link here if this one is deleted? Now it doesn't point to this one, it points to this one. So but remember, there is the same inode. So I think my answer would be that nothing happens. Like it would just be the same, right? Why? Because you're not deleting the data itself, you're deleting the reference to the data. So let's try it. So we're gonna do rm, and now we're gonna delete the hard link to the original file. All right, and then we're gonna look at this. So yeah, it's completely the same. So that's not that interesting to me, honestly. Like the interesting question, and this might be a question others would find interesting as well, is what happens when we delete this original file here, because this points to the same inode information. It's the same file, but with a different name. But the target of the soft link is this, even though there is a hard link to it here, which links to the same data. So what happens if we delete this? That's what's more interesting to me. Let's try it. Okay, so what happens is the link turns to red and it appears to be a totally dead link. Now, if we rename receipts to recipes using the move command, now the link is valid again because it's the same data and it has the same name in the link. All right, so let's take a look at the official answer. The soft link, oh, really interesting. Okay, so the soft link would stop working. This is because soft links point to names. Oh, I think they got it wrong. I think what they meant to say is what would happen if. I think they meant to say what would happen if the file recipes.txt is deleted. So let me ask the AI about that. So let me see here. So is there a mistake in this question? Did they mean to talk about what happens when you delete? Did they mean to show what happens if you delete recipes.txt instead of recipes.txt? Yeah, see, that's a mistake.
Yes, it appears there might be a mistake or confusion in the question. The question asks what would happen to the soft link recep.txt if the file receitas.txt is deleted. However, based on the provided context and the explanation, it seems like the question should be asking what would happen if
exactly.
you delete recipes.txt instead of recetas.txt. If you were to delete recipes.txt, the hard link recetas.txt would still exist and continue to point to the same data on disk. The soft link recep.txt would remain functional because it points to recetas.txt, which is still present. So, to accurately address the question, it should be about deleting recipes.txt, not recetas.txt.
Exactly. Okay. So, but we did that in the lab. So, and we even showed that you can go ahead and rename the hard link and to the original name of the original file, and then the soft link just magically starts working again because it is that original target. Like, it's the same target, just with a different name when you make a hard link. So if you change the name back to the original name of the original target after you've deleted the original target, it becomes the exact same thing as the original target again, and your soft links start working again. All right, so number 2, explorational exercise. Imagine you have a flash drive plugged into your system and mounted on /media/your-user/flash-a. You want to create a link called schematics.pdf in your home directory, pointing to the file esquema.pdf on the roof of the flash drive. So you type the command. There we go. What would happen and why? So you would create a hard link, and it would fail because you're trying to create that hard link across 2 different file systems. The first file system is on the flash drive, and the second file system is on your system. So you can only do that using soft links. Okay, so the command would fail. The error message would be invalid cross-device link, and it makes the reason clear. Hard links cannot point to a target on a different partition or device. The only way to create a link like this is to use a symbolic or soft link, adding the -s parameter to ln. Perfect. All right, so not even close to the final question. All right, so question number 3, which I will take a break. I'll be right back, and I will hit pause, not stop this time. All right, I'm back. So let's keep going with these exercises. I'm trying to walk backwards now. I think that'll be a good thing. Let me pull. Sorry. Here we go. Still kind of figuring out this for the first time, but okay. So, yep, we got this one. 100% full credit for that. You cannot create hard links across different partitions or file system types, but you can with soft links. All right, so consider the following output of ls-lah. Okay, so it's the -l, it's the -h, so we got the there. We've got -a, so all the hidden folders and files. So there aren't any besides the default. And then we get the -l, so the types and the permissions. So how many links point to the file document.txt? Sorry, I got a stone in my foot there. Okay, so let's take a look at it. So there we go. My answer is going to be 4, and then it's going to be that they're hard links, and we know that because soft links don't increment that value. And then which parameter should you pass to ls to see the inode of each file occupies -I. All right, so let's see what the real answer is. So how many links point to the file document.txt? So every file starts with a link count of 1. Since the link count for the file is 4, there are... Oh, okay. Well, I got that wrong because you have to deduct the link to itself, basically. So how many other files point to it? Well, you can't count the self-referential point, number 1. So the answer is 3. I get no credit for that. Every file starts with a link count of 1. Since the link count for the file is 4, there are 3 links pointing to that file. 0 credit. Dun, 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 dun. All right, so are they hard or soft links? They are hard links, since soft links do not increase the link count of a file. Full credit for that one. Next one, which parameter should you pass to ls to see which inode each file occupies? The parameter is -I. The inode will be shown as the first column in the output of ls, like below. All right, so full credit for that one as well. Looks like some sort of Hawaiian island or something. Lahai. That sounds wonderful. Although the weather here is very good, so... All right, so number 4, imagine you have your home/documents directory. You have in your home/documents directory a file named clients.txt containing some client names and a directory named some dir. Inside this, there is a different file also named clients.txt with different names. To replicate this structure, use the following commands. All right, so all right, so yeah, let's do the hands-on portion of this. So I'm gonna follow along with that. So inside documents, so imagine you have in your a file named clients.txt containing some client names and a directory named some dir. So let's create a in the documents. So let's go into the documents. There we go, and then let's go into backup just to see what that is. Okay, that's just part of. So we're gonna remove that. There we go. And now let's follow along with this exercise. So imagine we have a file named that. So let's create that. Containing client names. So we've got to load up the client names to it. So one thing we can do is t direct clients txt, and we don't have to open a editor. Just type in okay, or we could do the echo, but this is a way to do it. Okay, so and a directory named sumdir. So let's create the directory mkdir sumdir. All right, looks good to me. Inside this, there is a different file, also named clients.txt, with different names. To replicate the structure, use the following commands. So I'm replicating it as well. All right, looks good to me. You then create a link inside sumdir named partners.txt pointing to this file with these commands. And we're creating a soft link through the -s. So let's follow along with this. So this is the name of our link, kind of like a shortcut, you can think of it. So the directory structure is this, and it looks like they're using the tree command to get that. I do have the tree command, so I will use it as well. So there we go. They've got the clients.txt, some directory, clients, and then I've got a shortcut back to there. Now you move partners.txt from some dir to the clients and list its content. Will the link still work? So let's think about it. So now notice how the target is defined. It's defined as an absolute path. So my answer will be no, it won't work. But let's see what the correct answer is. So we're going to move in some directory partners.txt. We're going to move that here to this directory. So now if we do a tree, we've got it here, but we can see it's an absolute path. Sorry, it's a relative path, not an absolute path. So I don't think it will work. Let's try it. So less partners.txt. Okay, so this is interesting because it does work. It says that it says that it is different. Okay. So here's the answer. We'll do tree first. So it will work because all it's doing is it's creating a shortcut to this target, and this target exists. There is a file here named that. The file has different contents, but it's the same file name. So yeah, it works, but it has the contents of this file displayed, not this file, because all it's doing is it's pointing to this target absolute to where it is. So if there's a target with the same name but different data, it's still valid to the soft link. All right, so let's read the official answer. So yeah, so this was a good one because it demonstrated this fact with soft links that you're not linking to the actual data like you are with hard links. You're just linking to a target, and if that target exists, that's where the soft link goes. So the target does exist. here, but it's with a file that contains different data than the original file where the soft link was created to point to. Okay, so this is a tricky one, but the link will work. And the file listed will be the one in home/documents, containing the names John, Michael, Bob. Remember that since you did not specify the full path to the target, clients.txt, and let me, sorry, it's, oh, okay. Sorry, I was concerned that my treadmill was out of alignment there. Okay, remember that since you did not specify the full path to the target clients.txt when creating a soft link partners.txt, the target location will be interpreted as being relative to the location of the link, which in this case is the current directory. When the link was moved from home/documents/somedir to home/documents, it should stop working since the target was no longer in the same directory as the link. However, it just so happens that there is a file named clients.txt on home/documents, so the link will point to this file instead of the original target inside home/somedir. To avoid this, always specify the full path to the target when creating a symbolic link. Yeah, so that's, to avoid all of this confusion, you don't have to confuse yourself. All you have to do is specify the full target and you're fine. So let me do one more demonstration here just on my own before doing the last explorational exercise. We're going to go into somedir. Now we're going to create a new soft link to but we're going to create it using the full path. Okay, and then we're going to call it full path.txt. There we go. And now we can do the tree. Okay, now let's see what happens when I move this one up to that other one as before. So move full path up. Okay, and then tree. There we go. So now we can see that it is still pointing to the clients.txt. Let's do less full path. Wow, that's kind of fascinating. Oh, right. No. This is what I meant. So yeah, so now it doesn't break it, and we get so if we cat out the clients in this, we've got John, Michael, Bob. If we cat it out in some dir, now we've got Bill, Luke, and Carl. If we cat out the shortcut full path, Bill, Luke, and Carl. There we go. So now what happens if we delete the clients in here? And then we do tree. Now we can see that the link we created before that now is absolute and points to this file here still works, but the absolute link is now in red. And if we try to cat it out, it says no such file or directory. All right, so the next question, consider the following files. There we go. So we've got a soft link here, and then we've got it's absolute. What are the access permissions for partners.txt and why? So I'm going to say the access permissions are the same as the target because it's a soft link. Let's see if I'm correct. So the access permissions for partners.txt are rw-r-r-r, as links always inherit the same access permissions as the target. I was right. Full credit. Good for me. All right. So, oh man, we're so close to taking the test. This is exciting times. Summary. In this lesson, you learned what links are, the difference between symbolic links and hard links, how to create links, how to move, rename, or remove these links. The following commands were discussed in this lesson. ln, the link command. By itself, this command creates a hard link. With the -s switch, a symbolic or soft link can be created. Remember that hard links can only reside on the same partition and file system, and symbolic links can traverse partitions and file systems, even network attached storage. The -i parameter to ls, which allows one to view the inode number for a file. All right, so that's it. Stay tuned for the final lesson before I finished all the materials and I schedule the exam and then do some review lessons and then let you know whether I passed or failed. So exciting times ahead. Thanks for watching and stay tuned for the next one.